All right, and now for part 2 of the 2019 exam 2, and that's the 20 multiple choice questions, or 19, or whatever we wrote, I can't remember. All right, so let's get started on this section here. So what we're going to do with this first question is equate the bases. So we've got 5 to the 2 to the 2 take x equals 5 to the 3. So the bases are the same, so we're going to let them equal to each other. That's 4 take 2x equals 3, negative 2x equals negative 1, x is equal to a half. All right, question 2, an application of some log laws, and again it's the same style of question of equating log bases here. So when two logs with common bases are being subtracted, we divide it. So we're going to get log b of x plus 2 all over 4 equals log b 3x. And so what we're going to do is just equate these two here. So x plus 4 on x plus 2 on 4 equals 3x. X plus 2 equals 12x. What do we got here? 2 equals 11x. X is equal to 11, or 2 on 11. There it is, there. Okay, all right, straight up derivative here. You can expand that. It's probably going to take me longer to do this on the calculator, so I'm just going to say g of x equals, what do we got? X to the 4 take 2x squared. G dash x equals 4x to the 3 take away 4x. Okay, now this one here, what we're going to do is find f dash x and bang 0 into the derivative function. Rather than expand that nasty thing or try to do the product rule, I'm just going to define f of x equals x squared take 3 multiplied by x squared plus 2x plus 6. It's going to diff f of x, which gives us that. And we're going to do the answer with x is equal to 0, negative 6. Okay, the equation of the normal to this function at x is equal to negative a half is one of these. All right, so let's do it. Define f of x equals x to the 3 take 2x. And what we're going to do is go to calculation line, and we're going to get the normal for f of x when x is equal to negative half. Right, there it is there. All right, so we can see here that what we've got is a form question here. Yeah, good distractor, but that's negative when this is a positive. So we're going to manipulate the form so it's not, or it's neither of those. Right, let's just see. Okay, so what I'm going to do is say, I'm going to write here y equals a and s, and that gives me y equals the function. Okay, so now what I'm going to do is try to get rid of this denominator here, because there's no denominator and there's no denominator here. There is one here. So what I'm going to do is actually get rid of the, divide by 8. Look, let's just multiply the answer by 40. And we'll simplify that. All right, so there it is. When multiplied by 40, that's what we get. 40y take away 32x equals 51. It's E. Oh, I think there's an error on this one here. I've corrected it here. This solution will look different on your solutions here. So we did accept both D and E on your papers. So this one here would have also been correct, but I've updated the paper to make that an incorrect option. So that was the one I originally intended when I wrote the question for it to be the correct one, but you would have also got the correct answer if you selected D on the actual exam that you guys did. Right. This one here, we're going to bang x is equal to 2 into this function here. Now it looks like when I put it in, I'm going to get a divide by 0 error, but that's not the case. Okay, so what you want to do is just factorize that that top line there, x squared, x take 2 all over x take 2, and lo and behold, those two cancel out. Put x is equal to 2 into there, and we're going to get 2 squared, which is equal to 4. There it is there. The calc does limits as well, so it might be worth just showing you that quickly. Where's limits? I don't often get it to do it. Yeah, here it is. Limit as x approaches 2, shift divide. You can see why I don't use it. It's just quicker to kind of factorize and play with the form a bit. X take 2, there it is, 4. All right, period of the graph of y equals blah, blah, blah. Okay, so the tan function has a standard period of pi, and we're going to divide that by pi on 5, which is pi times 5 over pi. Pi's cancel out. There's our answer. All right, so what we want to do is get the range of this sine function. Now, what's going to happen is between negative 2 pi and 2 pi, so what's happening is it's going up 1, and so our sine function is going to start at the vertical translation, and it's not reflected, and it's going to go 4 and negative 1 and kind of go like that. So it's negative 2. What am I doing? Okay, so, and it will include those points at either end. So it's going to be negative 2 included all the way up to 4 also included. Negative 2 up to 4, y is an element of, yep. Graph has an amplitude of 4, period of 3 pi. The graph could have the rule given by. All right. So what we're going to do is it's going to be, well, they're all cosines. So it's going to be cosine something plus 4. So that one's obviously out. Oh, no. Ooh, whoops. Okay, steady on there, Paul. All right, so this one has an amplitude of 4, which means that that's 4. So those two are out. We don't know anything about the vertical translation, so it could be those 3. Right, so it's got a period of 3 pi. So standard cosine graph has a period of 2 pi over a particular value will give us a period of 3 pi. That's going to be 2 pi over 3 pi equals n. Cancel. Our n value is 2 on 3, and that is our answer there, D. Okay. Okay, well, these ones are tricky, these ones. Okay, function is continuous cubic function. All right, so we've got a cubic function here. Right, so what do we know? F dash negative 4. So when I put negative 4 into the derivative, I have a 0 gradient point. So there's a turning point somewhere along that line. All right, what else do I know? F dash 0 is equal to 0. So when I put 0 into the derivative function, I get a gradient of 0. So there's a turning point somewhere along this line. F dash x, so the gradient function is less than 0 between negative, so it's got a negative gradient between negative infinity and negative 4. Okay, so the gradient is going to be negative. Okay, so what's going to happen is it's going to come in here and maybe turn like this. All right. And it's got a negative gradient from 0 to infinity. So what I'm expecting to happen is going to come in and go like that. All right. And let's just check f dash. So it's got a positive gradient between negative 4 and 0. Yep, got that. Right, so that could be the function. So let's see. It must have. Well, you can see here, I've drawn one here that meets the requirements, and it only has one x-intercept. How many stationary points? 1, 2. So it's got 2 stationary points. Stationary point of inflection at x is equal to negative 4. Well, you can see I've drawn it with a minimum turning, local minimum. Stationary point of inflection, no. A maximum turning point at x equals 0. Bing, 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 bing. That's our winner. So it must have that. for this to be the case. All right, 11. So we've got basic null factor law here. 3 to the x equals 0, or 3 to the x take 27 equals 0. That means that over here, x is equal to nu. 3 to the x can't be equal to 0, okay, because if you consider that function there, 3 to the x, it never is equal to 0. So let's go 3 to the x equals 27. 3 to the x is equal to 3 to the 3. X is equal to 3 only. We've got a unit circle here. Length of the vertical dotted line shown represents. So we're after the length of this line here, which is given to us by this y value here, which is sine. That's the only one. There you go. Pretty easy. Probably could have done a bit of that, a bit better than that with the distractors, but let's just check it out. So we're starting at pi, going back theta degrees. Yep, that's it, pi. So this one here. All right, I'm not interested in doing this by hand. I actually find trig solves a little bit tedious, to be honest. So let's get the calc to do this one. We're going to go solve tan 2x is equal to -1 over shift root 3 for x with a value, what's the domain? 0, and let's include those points, less than x less than 2, shift 0 for pi. All right, oops, what was that? 1, 2, 3, 1, 2, 3, 4. Over 12, over 12, over 12. Yeah, so you can see here they've got the undilated solutions here. I mean, why you be doing that by hand? I just don't know. I mean, it's the great thing about calcs is they just slam out a solve like this. All right, okay, getting to the business end. Now we've got graph of this has a stationary point when x is equal to 2. All right, so what I'm going to do for this one is define a function, define f of x equals x cubed plus b times x squared, take away 4. All right, now again, if you're looking for b like a parameter, you just go into a, b, c and choose a parameter from there. But yeah, I've got this keyboard in front of me, so I can just use that. All right, now it has a stationary point when x is equal to 2. All right, so what we're going to do is diff f of x and do it with x is equal to 2, and we're going to solve that when that's equal to 0, okay, because it has a stationary point, which means the gradient function is 0 when x is equal to 2. And we're going to solve that, not for x this time, but for b. B is equal to -3. There it is. All right. Oh, it's a bit of a tough question here. Well, it's not tough, it's the Pythagorean identity, but there's a bit of work involved in this. Okay, so what do we know? We know that we're in 4th quadrant, somewhere there. All right, so what we know is the cosine value is 5 on 8. What we've got to do is get the sine value there, and then we'll just do sine on cos equals tan. What do we know? We know that the tangent is going to be negative there. All right, so see you later, U3. And we're down to 2. I mean, we've got a 1 in 2 chance now. That's pretty good. Okay, so what we're going to do is use Pythagoras theorem to get this. Yeah, let's use Pythagoras theorem. All right, I'm going to do this a bit by hand and just see how this works out. So just going to knock together my triangle. That's 5 on 8. This is 1 because it's the unit circle, and that's what we're after. So we've got This is going to be the shortest side length, so let's just call that b squared. B equals the square root of the hypotenuse squared, 1 take away 5 on 8 squared, all right? And what that's going to do is give us this value here, but I know that that's negative, but I'm not worried about that just at the moment. All right, so I'm going to go back to, not there, I'm going to do shift square root 1 squared, which is 1 take away 5 on 8 all squared. All right, that's looking okay. Now I know that that value is negative. All right, so I'm just going to do that negative answer. That gives me that one there. And what I know is that tan is equal to sine on cos. Okay, so what I've just worked out, that one there is sine, negative root 39 on 8. So what I'm going to do, that's sine on cos, it's that all over 5 over 8. There it is there. I mean, once you worked out that, yeah, that distractor was written for just getting sine, you pretty much know that that's going to, or that has to be the answer there, but it's good to know that that came up. All right, the Cartesian coordinates of the trig point P 7 pi on 6. Okay, so different question. I remember seeing this one and thought, yeah, that's a good question, that one. So here's 6 pi on 6, this is 7 pi on 6. So that's 30 degrees, or what? That is pi on 6 there. So what are the coordinates here? Well, that's going to be the cosine of pi on 6, the negative one of that. So cosine pi on 6 is 30, what's that? That's like root 3 on 2, negative. And sine of 30 is a half, that's going to be negative a half. There it is. Right, these come up in Year 12 exams all the time, those ones. We've got f of x there, and we want the derivative function. Okay, so which one? So what we've got here is we've got a 0. So this is the original function. So we've got a 0 gradient here and a 0 gradient here, which means that we're looking for a graph that goes through 0, 0, 0, and negative 3, 0. So that goes through 0, 0. That's A's gone, because it doesn't go through negative 3, 0. Because remember, what this represents is f dash x, the gradient function. So this should say that the gradient is 0 at this point. It's saying that we've got a massive gradient. Well, not massive, but like the gradient's 4. And I disagree. The gradient at negative 3 is 0. Right, so that one could. That one could. I'm just going to see if we can get rid of anything else. What on earth is that? That's the modulus function. New. Could be. Okay. Let's see what else we know. All right. So what we've got to the left of negative 3, we've got a negative gradient. Okay, so the gradient is negative to the left of this 0 gradient point. All right, so let's just see where that happens. There's only one. All right, so this is gone. So if you look at negative 3 here, it says to the left of negative 3, we've got a positive gradient, because this, remember here, is at a positive value for y or a positive value of f dash x. This one here, we've also got a positive gradient to the left. This one here is the only one where f dash x is negative, so the answer's got to be D. What we've got a rule as follows, and we want to do this. Well, I think the simplest way, rather than substituting into that, is just to define f of x equals 3x squared take 2x plus 5, and do f of x plus h take away f of x. New. All right. 6x plus 3h take 2. There it is, A. All right, 19, nearly there. F of x is that. F dash A equals negative 11. All right, let's start with f of x. Define f of x equals negative 2x squared, take 7x plus 8. Let's diff it. Diff f of x. Do it with x is equal to a. So we want to put a into the derivative function and let the derivative function, so solve for the derivative when it equals negative 11, comma, a. A is equal to 1. That was a very similar question to one early in the paper. All right, and on to the last question. Oh, where's my mouse? Okay, so for this one here, we've got graph of f of x, it's a parabola, graph of h of x, straight line. The graph of h of x is a tangent to y equals f of x at 1, 2. So at 1, 2, that is the tangent, or the equation of the tangent, h of x. Okay, and we'll after which one is not true. F of 1 equals h of 1. So f of 1 is 2, and h of 1, well, it's a tangent, and it's the tangent at there, so that's absolutely true. All right, f dash 1. So if we're looking at this one here, f dash 1 is the same. So the gradient of f of x at 1 is the same as the gradient of h of x at 1. Yeah, they're the same because it's the tangent. That's true. Okay, f dash 2. So the gradient at 2, which is 0, is the same as h of 2. Okay, and h of 2, when I bang h of 2, that's 0 as well. That's true. All right, they're making us wait for this or work for this answer. All right, f of 1, so what's f of 1? That's 2, is the same as the negative version of h dash x. Where? What is h dash x? Oh, okay, yep. So here is this function here. Oh, yeah, that's a good distractor, that one. So here it is here, and what we've got is a function that has a gradient of, as x increases by 1, the y values will go down by 2. Okay, so for every increase of 1, the y values go down by 2. So m is equal to negative 2 all the way along this line here. Okay, so our function is going to be y equals negative 2x. What's the y-intercept? Plus 4. Now note then that the derivative dy dx is equal to negative 2. Okay, so the gradient here of h dash x is always going to be negative 2. This is negative 2. Negative 2 is 2. Now what was f of 1? F of 1 is 2. Ah, that's true. So this one here must be false. All right, let's find out why. F dash 2, so the gradient at 2, which is 0 here, is the same as the gradient at 2 for this. Well, no, it's not, because we just worked out that the gradient all the way along this line is negative 2, and the gradient at f dash 2 is 0. 0 is not the same as negative 2. That is false. All right, so there's the multiple choice.